Hi, this is a recording of the final exam for the last few questions, the question number 4, 5, and 6 for the practice final exams. So what I'll do is I'm going to download the exam itself and show you the answers to that. So let's take a look at those questions. Alright, so let's start with question number 4. And with question number 4, the question is you have to implement a function called isSorted, and its function is to figure out whether all the characters within the array buffer or within the parameter buffer here are sorted or not. And they have to be sorted in a non-decreasing order in order to return a true value or non-zero value. If anything is out of order, the function is supposed to return a value of 0. So there are several ways to do this. The first one is the iterative way of doing this, and it's supposed to be the easier way. I think the two methods are about the same. So what I'll do is I'm going to use that method first. So what I'm doing right now is to declare a local variable called result, and we can give result a default value of 1, which means that by default we are saying the buffer is sorted until we find evidence that it is not. And we'll also go ahead and declare a local variable I so that we can focus on one pair of elements at each iteration of the loop. The loop is going to be a for loop, so we can initialize I right at the beginning. We can also initialize result here too, so we could have put result equals 1 here. It's not that important. So what we want to do is to say we're going to exit when result is not true, because as soon as we can confirm that at least one pair of elements or adjacent element is not sorted, we can actually get out of the loop right away, because there's no way to make the result true again after that. But at the same time, we also want to we want to make sure the result is true, because as soon as it becomes not true, we want to get out of the loop. And we also want to make sure that whatever character we are looking at, which is buffer I, the element I in buffer, has to be a non-null character, as well as the one that is after that also has to be a non-null character, and the one after that is buffer I plus 1. Now, because of the conjunction in C is it uses short-circuited evaluation, we can do it this way, because if the first one is false, it won't even bother to evaluate the second one. So we are not going to access any array element that we are not supposed to. And then we put plus I at the end here so that we don't forget to increment and move to the next position. There's not much to do in the loop here. The only thing we have to do is to indicate the result, which basically means, is buffer I less than or equal to buffer I plus 1. So we can just put that expression here and say, buffer I is less than or equal to buffer bracket I plus 1. And that's it. That's all we need to do inside the for loop. And when we get out of the for loop, we can just go ahead and return result here. And that's my entire subroutine. Alright, so let's go ahead and check whether the solution as it is right now works or not. So we'll go ahead and compile Q4. And go ahead and run it. So we can give it something that is by default sorted, which is like an empty string. And it said it's not sorted. That is not good. But let's go ahead and try something else. Okay, with one single character, it is considered to be sorted. And with ABC, it is considered sorted. And let's try one more. Let's try BCA, and it is not sorted. Alright, so right now the only case that is not working is when the string is an empty string, which is the first case here. I did not type anything, and I just pressed the enter key. And so with that case, that's my mistake here. I is supposed to start with 0 because all the index elements or all the elements in an array should start with the index 0 in C and C++. Alright, that is a weird mistake that I make. Alright, empty string, it is sorted. String of only one character is always sorted. And ABC is sorted. BCA is not sorted. So we got question number 4 implemented. But I do want to present you with a alternative way to implement question number 4, which is the recursive way. So let's take a look at the recursive way and see how that works. So we'll go ahead and delete all the code here. And the recursive way works in a kind of interesting way. We basically look for all the trivial cases first. So one of the trivial cases is, what if I'm given an empty string? In other words, the only element, the first element in buffer is already a null character. Now we can say that this is 0. Okay, this is a clear way to say it. But because anything that has a value of 0 is also considered false, not buffer bracket 0 is considered basically the same thing as buffer bracket 0 equal to 0. So in that case, we can say return right away and say yes, it has to be sorted. Now in the else case here, we have to say, okay, we know the first character at index 0 is a non-null character. What about the second one? Because if the second character is a null character, even if the first one is not, then we have an array or a string of only one character. If you only have one element in an array, the array has to be sorted. So in this case, we can also just return 1 for sure. Now what if you have at least 2 non-null characters? In that case, we'll check the easy one, or we'll try to find the easy answer first. Okay, the easy answer is these 2 characters that are non-null. They're both non-null characters, but they're out of order. So we'll check for that case first. So to express that condition, we basically say buffer bracket 0 is actually greater than buffer bracket 1, because the first character is larger than the second character. And in that case, we know for sure the array is not sorted, because it just takes one pair of elements to be out of order for the entire array to be out of order. So the only really complicated case here is this one here, which is basically representing the string itself is not null, because if it were null, this condition would have been true. It does not have one single character, because if that was the case, this condition would have been true. And it is also cannot be confirmed to be not sorted, because otherwise this condition would have been true. So in this case, we're basically saying, okay, the 2 characters that I look at, the first 2 characters, are both sorted, but we know this is not the end of the entire string yet. So the next thing to do is to basically say, okay, I am only going to check the first 2 characters, but for anything after that, we'll defer to another subroutine to check. So we're going to say whatever that subroutine returns is whatever I'm going to return, because if we find any elements to be out of order later on in the string, then the entire string is going to be not sorted. So we'll just go ahead and defer that to the other subroutine. But the other subroutine turns out to be just is sorted as well, which is where we are in at this point. But the parameter is the funny part, because in this case we're passing the address of buffer bracket 1 here. So instead of passing just buffer, which is the beginning of the array that I'm given with, I'm basically now saying, okay, let's start with the address of the second element of this array. So to the next invocation of is sorted, that is considered to be the beginning of the entire array. Let me say that one more time. as far as the current invocation is concerned, this is the address of the second element. But when we pass the address of the second element of the current invocation to the next invocation, as far as the next invocation is concerned, its beginning, the first element, is actually my second element, and my in this case is referring to the current invocation. So this is the power of recursion. It basically takes a problem and break it down into different cases. In this particular situation, the simple cases are all the way up to this point here, which basically says, okay, we'll handle all the cases where we have a definite answer right away, and we can just return to the caller and say, yes, it is sorted, yes, it is sorted, or no, it is not sorted. But in the event that I cannot make that decision because I have to take a look at the rest of the array, I call the subroutine again. I basically reduce the size of the problem by 1 when I call is sorted again. So eventually this will become the null case, or the trivial case, one of the trivial cases, because the string basically gets shorter and shorter as I perform the recursion. Alright, so let's go ahead and see if this one works. Let's check the empty string first. It is considered to be sorted. Let's check a string with one single character. It is considered to be sorted. Let's give it something that is actually sorted. Okay, it is reported back as sorted. And let's give it something that is not really sorted, and it is reported back as not sorted. So that works also. So I'm hoping that this kind of helps to illustrate, why recursion is useful. Let's go ahead and take a look at question number 5 then. Question number 5, if you go all the way to the bottom to read the question here. So the question is, if A, B, C, D, E, F, G, and the line feed, which is the end of line character, is the input, what is the output of this program? So right now, it's easy for me to just test run the program and tell you what the answer is. But instead of doing that, we're going to check out the code here and try to figure it out, step by step. Alright, so we have a const int array size here, which is basically just defining array size to be 5, and it is, because it's a const, that means nowhere in the program can I change this particular quote-unquote variable. It's no longer really a variable because it cannot be changed. We have a structure here, and this structure is kind of funny because it has a char v, which is not really surprising, but at the same time it has a ptr member, and that is a pointer to a struct x. To some people this may look kind of confusing. How can we make use of struct x when we're still defining it? To that question, the answer is any pointer is basically the same. Okay, in other words, I don't need to know what a pointer is really pointing to know how many bytes I need to reserve for that pointer, because all pointers in a 32-bit system would have 4 bytes or 32 bits, and all pointers in a 64-bit system would have 8 bytes, which is 64 bits. So in this case, even though struct x itself is not fully defined yet when we encounter this line, is not an issue, because as far as the compiler is concerned, it just needs to know, okay, I have to reserve 4 bytes for PTR in a 32-bit system. That's all the compiler needs to know. It doesn't need to know the entire actual definition of struct x at this point. Moving on into the main program. In the main program, we have an array A, in this case, of struct x's, and we have array size many elements in it, and in this case, because array size is defined to be 5, so that means we have 5 struct x elements in array A. We have integer I, and we have a pointer ptr that points to a struct x. Those are our local variables. And then we have this part here initializes PTR to be A. So what that really is doing is saying that PTR is pointing to the first element of array A, which also turns out to be the beginning of the entire array. And that's why this particular assignment statement works just fine, because the beginning of an entire array of struct x is the first element of the entire array, which is the address of a struct X element, and PTR is a pointer to a struct X, and it's just kind of work out. The loop here is initializing from where I goes from 0 to array size -1, and plus I means at the end of each iteration we increment I. And the way that works is we are reading in directly into a bracket I dash v, and that turns out to be it's just based on I. So we're basically reading characters one by one into the v member of each element in array A, and we're just going to read it one by one. So starting with a bracket 0, a bracket 1, a bracket 2, a bracket 3, and that would be the last one that we're reading in, because by the time I becomes 4 we actually get out of the loop. The next statement, which is this one here on line 23, is actually the kind of interesting one, because what this is really doing is it is making the PTR member of one element in A point to the next element in the array, which is a bracket I plus 1. But you can see that we are taking the address of that. So basically we're making pointer point to the next element. And when we get out of the loop, when I does equal to array size -1, which means that's our last element in the entire array, PTR is getting a value of 0, so it's a null pointer. The null pointer basically signifies this is the end of the list. Do not follow this pointer because it points to a location that we cannot go to. And then the last statement here is the real question. So we have to look at this expression here and try to figure out what it does. Okay, so what I'll do is I'm going to what am I going to do? Oh, what I'm going to do here, sorry. What I'm going to do here is to decode this, step by step, and try to figure out what it is actually going to print. Okay, so let's take a look at where we are changing PTR. If you look through the entire code here, PTR as a variable but not as a member of a structure is only changed all the way up here. It is the beginning of the entire array A. Other than this, it doesn't get changed, because all the other mentioning of PTR, such as this line here and also this line here, they are referring to the member PTR of a struct X, not our local variable PTR. So those two PTRs are actually different. Alright, so let's go ahead and see if we can document this. So PTR itself is the address of a bracket 0. Okay, so we have a bracket 0 here, but it is not actually a bracket 0, it is the address of that. This asterisk symbol, which is dereference, applies to this thing here. Well, you can see that the asterisk is dereferencing, and then the ampersand is taking the address of, and these two operators basically cancel out each other. So that means this part here, which is asterisk PTR, is really just saying a bracket 0. Okay, not the address of, it is just a bracket 0. Okay, that is not too not too bad. And then the next thing is the dot symbol here. Now I'm gonna have to clarify a little bit here and basically say that the implicit order is like this. Okay, so the dot symbol or the apostrophe s is applied first before the dereference is applied. Okay, so now that we know that order, this becomes just a bracket 0 dot PTR, and that refers to the expression all the way from here to here. That is just a bracket 0 dot PTR. That, according to the way we work with the array, is the address of the element next to a bracket 0. Well, the element next to a bracket 0 is a bracket 1. Okay, so we have a bracket 1 here, but it's the address of a bracket 1. It is not the actual a bracket 1. It is just the address of that particular element. Okay, so this ampersand a bracket 1 is referring to this particular expression here that evaluates to the address of a bracket 1. After this, we apply the asterisk symbol here, we dereference. So we basically end up with the dereferencing of the address of a bracket 1, and as I said a little bit earlier, the referencing and the address of are two operators that kind of cancel out each other. So what we end up with here is really just a bracket 1, and that refers to the expression from here all the way to here. That is considered, one. Oops, excuse me. That would be this expression here. I just need to match up the parentheses. So that becomes just a bracket 1, and the dot v is applied to a bracket 1. So that means a bracket 1 dot v is the entire expression. This entire expression is a bracket I dot v, which is the second character that we are reading in from standard in. Alright, so now that is solved, the second character is actually the letter B, so that should be the output of this whole program. Is really just the letter B followed by a line feed character like that. Alright, so let's go ahead and check whether that's actually what the program is going to do. So we say G++ -o q5 run the program, give it A, B, C, D, E, F, G, press the enter key, and the output is exactly just the letter B. So that's for question number 5. And here comes question number 6. I think that's our last question in the practice test. Okay, so here's question number 6. And what it does is, once again, it has array size equal to 5, and it's a constant. And that means I really should have used that here. Okay, so array size doesn't really matter. 5 is 5. Whether we use the constant defined up here or just spell out 5, they're still pretty much the same. And I am alright. This one is actually this is embarrassing because I did not, actually finish the whole program. I copied and pasted a whole bunch of stuff, but then forgot to go back and modify it. All right, so now it's modified now. Okay, so what we have here is we have 5 integers, and these are 5 local variables. A, B, C, D, E. They're all local variables, and then we have an array. Now this array is an array of integer addresses. How do we know that? Because of the asterisk here. So the way we read this is addresses is an array, because of the square bracket here, of 5, which is array size, of pointers to integers. So it's basically an array of 5 integer pointers. And then we have min as a local variable, I as a local variable. The question is asking that we should write code here to find the minimum of variables A, B, C, D, E, and store the not the maximum, minimum, and store that minimum in variable min. You are only allowed to use the array addresses, the array of addresses. Okay, back grammar here. The array of addresses. The variable min and the variable I do not access variables A, B, C, D, E explicitly. Alright, so let's try to figure out how to get this done. Because we have an array of 5 integers, so we kind of know what to do with the array indexing, because we start with the first element. This 0 is the index of the first element. We want to stay in the loop as long as I is less than, and I forgot the name of the const here, array size. Okay, so array size is the number of elements, and we want to make sure that I is less than that to stay in the loop, because when I does get to array size, it's no longer a valid index into the array. And if at the end of each iteration we want to increment I. So that's basically what we want to do to examine each and every element in the array. Now, one thing we also want to do is to initialize min to something. And there are several ways to do this. Some people initialize min to the largest possible value that an integer can store, which basically means anything that we see in the array cannot be larger than that, and that works too. But the other way to do this is to basically say, oh, let's pick the first element of addresses and say that min is the value of at that location. Okay, let me repeat that because this is actually kind of important. So it is not this that we want. Okay, if we do something like this, the compiler will complain because it is saying, okay, let's initialize min to element 0 of addresses, but all elements in addresses are addresses of integers, and min itself is an integer, and these two types do not match. So that's why this won't work. However, this will work because it is referring to what addresses bracket 0 is pointing to, and that turns out to be an integer, and min can be initialized to an integer, so this will work. Now, if you initialize min like this, you can actually start with 1 for I, because we don't have to re-examine the first element of the entire array. But that's okay. If you just leave it at 0, it will still work. It's just going to use up one more iteration that is not necessary. Alright, so in the loop here, what we're going to do is to say, okay, well, let's see if okay, this is a little bit hard to say. So we want to see if min turns out to be greater than the integer pointed to by the element at index I. That is the right way to say it. Okay, let me just repeat that again. We're comparing min, which is an integer, and that represents the minimum value that we have seen so far. And we want to check to see if that minimum is greater than the integer pointed to by addresses bracket I. Okay, because all elements of addresses are addresses to integers. So now we are using the asterisk symbol to dereference a particular address and say, okay, is the integer pointed to by this element actually less than min? Because if that is the case, min is no longer actually the minimum. So we have to update min to be the value pointed to by addresses bracket I. And that's it. If we find something smaller, we'll go ahead and update min. Otherwise, there's nothing to do. The loop itself, the post condition of the for loop, is already taking care of the incrementing of I, so that we don't have to worry about that. And that should be it. That code will find the minimum of the 5 integers. So now we can give it a test and see whether that works or not. So let's get out of this loop here. Let's get out of the editor and compile the program. And then just run it and give it 5 integers, in any order. So 6, 1, -5, 10, and let's pick 2. And it prints -5 is the minimum. So the code seems to be working. Let's give it 5 identical values and make sure that that also works. So we give it 5, 5, 5, 5, 5, and it prints 5 as the result. So the code does work. And at this time, we're going to take a quick look at question 3. I think we skipped this one in the late class, so we're going to have to work on this. Okay, so let's skip to the end of the program to see what the question is about. The question is, what is the output if the input is ABC followed by a tilde symbol and the \n, which means end of line, or pressing the enter key? And we also want to figure out what the output is if the input is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, and then the tilde symbol, and then and then the carriage return. So those are the questions. And so to get to the answer, we have to be able to figure this code out and find out what it's supposed to do. In this case, we have an array of 9 characters, PASSWD, which otherwise known as quote-unquote password in Linux, is an array of 9 characters. we have a local variable I that is of type integer, and a local variable ch that is of type char. It's just a single character. This part here initializes the elements in password. What we do is we use I to control which element in the array we are initializing. It starts with 0, which means we're starting with the first element of the array. We stay in the loop as long as I is less than size of password minus 1. Size of is an operator that tells you the number of bytes used by the thing that is inside the parentheses. In this case, password PASSWD is an array of 9 characters, and because each character is a byte, so size of password is going to be 9. But we don't want to compare to 9, we want to compare to 9 minus 1, because the last character is a null terminator, and that's why it is initialized out of the loop. At the end of each iteration, we have a ++I as a post operation, and the only action we specify in for each iteration is PASSWD bracket I equals to the ASCII code of the lowercase a character. So what this does is to initialize PASSWD to be 8 lowercase a characters followed by a null terminator. And then after that, we reinitialize I to 3 and perform this loop here. Now with this loop, the condition is a little bit strange, but it's not too strange, because the first one is the expression of cin right shift ch, and basically what it does is it's just going to read a character into ch. Now because we are using this whole expression on the left hand side of the conjunction symbol, we are basically evaluating the return value of the right shift operator applied to an input stream as a boolean, and that conversion automatically return true if and only if the read operation is successful, and it returns false if the previous read operation was not successful. So if we did read a character into ch, this part is going to be true. And with a conjunction, if one part is true, you have to evaluate the other part. It cannot short circuit when one part is true. So the second part is basically checking to see whether the character that we have just read is the tilde symbol. If it is not the tilde symbol, we stay in the loop. If it is the tilde symbol, we exit the loop. So by the time we get here, we know for sure that ch is not the tilde symbol. And whatever I is at that point is going to get that character, or I should say password PASSWD at that particular index will get ch. And we start with 3. So the most important part of this program is really this line. Okay, we have to figure out what this line is really going to do. What it's doing is it is adding 13 to I, and it's going to take the remainder of dividing it by basically 8 in this case, because size of PASSWD is 9. 9 minus 1 is 8. So that's the single most important part. So what I'll do is I'm going to use a comment here and basically indicate how I is getting updated because of this line. The first time I gets updated, I still has a value of 3. 3 plus 13, and the mod operator, the divisor stays the same all the time because the size of password does not change, and as a result it's always going to use 8 as a divisor. And the result of this is 16 mod 8, which is 0. And then the next time, because I would have a value of 0, then becomes 0 plus 13, and then we have mod 8 here, and that becomes 13 mod 8, which is 5, because 13 divided by 8 has a remainder of 5. And then after that we have 5 here. 5 plus 13 is 18. 18 mod 8 is 2, and then after this I is 2 plus 13, which is 15. 15 mod 8 is 7, because 15 divided by 8 has a remainder of 7, and so on. So we'll go ahead and just finish this part here. The next one is 7, because I will have a value of 7 at a time. 7 plus 13 is 20. 20 mod 8 is 2, because 20 divided by, oops, never mind. Okay, my arithmetic really sucks. It is 4, because 20 mod 8 is 2 with a remainder of 4. Okay, the next one is 4 plus 13, which is 17. 17 divided by 8 has a quotient of 1, but a remainder of, has a quotient of 2 with a remainder of 1. And then the next one is 1 plus 13, which is 14. 14 mod 8 is 6, because the division has a remainder of 6. And that should be the last one, because after that it goes back to the earlier part. So 6 plus 13 is 19. 19 mod 8 has a remainder of 3. I take it back, this is the second last one. And then we should go back to the beginning, because now I is back to 3. 3 plus 13 mod 8 is the very first item. We know that one already. Has a result of 0. So basically this pattern just kind of repeats. In other words, if there are any more characters to read, it would just overwrite these locations. Okay. All right. And just to be complete, I started off with the value of 3. Okay. So now we can kind of tell what characters will go into which position. With the first case, where the input is just ABC, that means A goes to the element at index 3, and then B goes to the element at index 0, and C goes to the element at index 5. Everything else, it would all be lowercase a. So that means the answer to the first part of the question is A. No, I take it back. It's B, because B is going to index 0. And then we have A, and then this is the fourth element. It is originally an A. We're overwriting with an A anyway, so it doesn't seem like it's changing. And then we have another A here. This is for index 4. This is for index 5, index 6, index 7. And index 8 is the no terminator. So that would be the answer to the first question. Okay, so we'll say B, A, C, A is the answer here. The other question, which is this one here, is going to be a little bit more tedious, but it's not impossible, because we know the first letter that we read is 0, the next one is 1, then we have a 2, 3, 4, 5, 6, and so on. So let's work this one out. The first letter is 0, next letter is 1, oops, and then we have 2, 3, 4, 5, 6, 7, 8, 9, and then we have A and B. There we go. Alright, and then the tilde symbol terminates the whole loop, so it's not really going to be a part of the loop here. And the tricky case about the second one is you have to read it backwards, because some positions get overwritten, like position 0, the element at index 0 gets overwritten here. So it is not going to keep the value of 1. It's actually going to be, actually I take it back, there are 4 positions that are overwritten. It will be this one, this one, this one, and this one. So these are overwritten like twice, because the first time we initialize to A, The second time is 0, 1, 2, 3. And the third time would be 8, 9, AB. Alright, so let's try to work out what's going to happen here. And I will start from the very beginning in this case. The initialization will initialize all 8 positions, or the elements corresponding to index 0 to index 7 to AAAA. And if we work our ways backwards, okay, the best way to do is actually to do it backwards. Let me delete this first, just copy and paste. The last character is a B. It is written to the element index 2. Index 2 is actually the third element. So this is the first, second, and third. So this position becomes a B. This one we don't really have to deal with because we're just overwriting a character A by character A. So it doesn't seem to be changed from our perspective here. And then we focus on the 9. This is going to overwrite the element at index 0. So that means this is going to be a 9 here. And then we have the 8. The character of 8 is overwriting the element at index 3, which is the fourth element. So we locate the fourth element here, and that's supposed to be 8. 7 is supposed to overwrite index 6. Okay, so index 6 is our second last element, which is here, and that gets a value of 7. And then the character of 6, digit 6, goes to the second position. And here's the second position. It's going to be a 6 here. The digit 5 goes to position number 5 because it has an index 4. So we have 0, 1, 2, 3, 4, and that gets a digit of 5. And the digit of 4 goes to the very last element. Well, this is actually the second last element of password, counting the null terminator. But if you don't count the null terminator, this is going to be the last element because it's basically corresponding to this one here. So let's work on it step by step. Copy and paste. Oh, I just did that already. Okay, so let's just go ahead and change this one to a digit of 4. And then the other 4 positions corresponding to this one, this one, this one, and this one, we don't have to do it because we're working backwards, and these would have been overwritten by B, A, 9, and 8 anyway, so they won't be represented. This will be the output. So the output of the second case is supposed to be 9, 6, B, 8, 5A, 7, 4. Okay. But let's go ahead and compile the program and test it out. And so the first case is ABC, the tilde symbol, press the enter key. It is B, 4 A's, 1 C, and then 2 A's, and I think that's the same thing in our answer. And let's run the second example. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. A, B, the tilde symbol, and then press the enter key. And in here the answer is 9, 6, B5, 9, 6, B8, 5A, 7, 4. And I think we have that in our answer. And this is another really cool trick here. You can actually search for a particular word or pattern in the file. So you specify the pattern that you're looking for, and then you specify which file you want to find this pattern in. And if it is there, it's going to find it and print that line. And you can see that we do have that line in the program. So that's just indicating that we did correctly predict the behavior of this program. So I hope this is going to help you get ready for the exam. I'm pretty sure I have said it before, but the most important part about this particular exam is the combination of concepts, not so much each individual concept, but the combination of these concepts. So I'm going to upload this video right away and send you guys a note so that you know the video is up. Alright, well, have a nice weekend, and don't forget to get ready for the exam.